Probably pronounced that wrong, from Avery Dennison SmartTrack. And she's going to talk to us today about green printing in the digital landscape from fab to mass production. Tina.
Thank you. Yeah, almost good afternoon, everyone. So my name is Tiina Vuorinen, and I'm the Printed Electronics and Novel Materials lead at Avery Dennison SmartTrack. Quick detail about my background. So I'm closing my 4th year with Avery Dennison, but I also have an academic background from my PhD years from Printed Electronics. Today, I'm trying to give you a small glimpse into the world of sustainable manufacturing of RFID with this presentation of green printing in the digital landscape from lab to mass production. A quick background story for Avery Dennison. So the story of Avery Dennison starts from 1935, from the world's first self-adhesive label that was used to merchandise products. Then Avery Adhesive merged with Dennison Manufacturing, and Avery Dennison was born. From that small company, Avery Dennison has grown to a global material science and digital identification solution company. And we have, the slide says 34, but I think the number might be already more than 35,000 people, and we are scattered across 50 countries. Then we come to a year 2020 when Avery acquired the RFID business from SmartTrack, and Avery Dennison SmartTrack was born, in which we are part of. And I'm actually located in one of our R&D sites in Tampere, Finland. Avery Dennison business can be divided into 2 groups. So we have a materials group that is involved in the traditional label materials, tapes, and graphical and reflective materials. Then we have the solutions group side, which we are part of. So we are playing in a field of RFID. And our intelligent labels are used to provide things like omni-channel retail, more efficient supply chains, enhanced customer experience, or maybe even reducing waste. Then the digital identification technologies that we are dealing with, maybe to point out one, the UHF, that is the biggest player in this team. Then what are we tagging? I would say everything. We have apparel, food, beauty, healthcare, logistics, and so on. Apparel is the biggest sector, but in the future, especially the food is definitely something that we are very interested in. Then the sustainability. In Avery Dennison, we see that the difference needs to be made in several frontiers. Of course, the main goal is the sustainable product, but also there is a corporate social responsibility, meaning that we want to support the communities globally. And in addition to that, the diversity and inclusion needs to be well covered. Probably like everyone else, also we have sustainability goals for the future. And the first one is the delivering innovations that advance the circular economy. This means that our products need to meet the recyclability or reuse requirements that the products that we are tagging are having. Then the second one, reducing the environmental impact. There can be multiple things, but some that are mentioned here, so the resourcing of sustainable materials, making sure that materials are not ending up in landfills, and then, for example, minimizing the water consumption on sites. And finally, making positive social impact. So very rarely someone makes innovations by themselves. So we definitely see that for great innovative solutions, the ideas come from mixed backgrounds and mixed perspectives. Then the sustainable production, so printed electronics and RFID. When we talk about sustainable product, of course we need to consider the sustainability all the way from sourcing the raw materials up to the end of life of the product. And from the materials point of view, the sustainability might mean different things for different products. So for example, if you buy a t-shirt with a hang tag that has the RFID tag, the sustainability comes from the sustainable materials so that the tag can be recycled immediately when you take the t-shirt in use. But what if the tag is following the product during its lifetime? Then it's more the durability of the materials, so that the tag is performing well the whole life cycle of the product. Then the manufacturing point of view. So there's few things that I especially like in printed electronics. Printed electronics has this sort of inbuilt system of saving the material. Since every millimeter costs money, in our case, this needs to be considered already in the antenna design phase. So we sort of cut away every part of the antenna already before manufacturing. And the second thing is that it's not just the footprint of the antenna that we can change, but by changing the printing parameters, we can also affect the thickness of the metal layer without the need of sourcing new thicknesses for metal films. Then what we have been trialing. So we've been trialing a roll-to-roll printed copper antenna on paper. And with this type of a product, we can combine three great things. So of course the additive manufacturing that we get from printing, and then the conductive material that is providing a good performance and price match. And finally, the paper substrate that will enable plastic-free products. But how do you get away from the lab into the mass production? I have divided the process starting from the printing phase until the end testing of the product. So I would say that the biggest difference between lab and the mass production is the high speed. So you definitely need to have a good game plan when you have your web running multiple meters per minute so that you don't lose a lot of antennas. The ink compatibility, this also relates to the high speed. So the internal structure of the ink needs to withstand the forces that it's experiencing in the high-speed printing. So that, for example, the solvent is not filtering away from the conductive particles. Stable printing. This means mainly, for example, like screen open time. So with fast printing speeds, we are depositing a lot of material through the screen, and we want to make sure that the amount we are having on the substrate stays continuous, even though we are printing for long times with high speeds. Substrate compatibility. In RFID, we of course want to have as many antennas per specific area as we possibly can to minimize the scrap matrix from the web. This means that we are also adding a lot of ink very fast on the substrate, and this cannot affect how the substrate goes in the production line. And in addition to the ink, we also have a wet tension that is different compared to sheet-to-sheet printing in laboratory. So we don't want to see a wrinkling of the substrate or even in the worst case, if you add a lot of solvent on a substrate, it might break down. Then the post-processing. So this is the part when we change the printed antenna pattern into a conductive form. I feel that in this step, you need the most modifications compared to the lab. So in lab, you can have your samples lying in the oven as long as you want. But of course, with high printing speeds, the time period that you have for the post-processing is usually very limited. So you might need to change the processing parameters, or you might even need to change the post-processing method completely. And again, substrate handling. The substrate needs to withstand the post-processing. As I mentioned, since it might need to be changed, we might need to heat it up more. So substrate needs to be stable, but also it is the web handling. There is a local stress point now that comes from the heating, for example, and the substrate still needs to travel nice and smoothly. Now we have the conductive radiator, but it's not an RFID tag yet. So after the post-processing, we still need to place an RFID IC and attach that with conductive adhesive. So ACB dispensing, there we need good adhesion and good wetting so that we can make a reliable connection. And then we place the IC on top of that, and it's usually cured with heat. And again, we are creating local stress points in the web with the local heating, and the web needs to stay without any deformations. Flexibility of the web. Quite often, the antenna will have other material layers on top of it. There might be adhesives and other substrate materials to sort of cover the antenna structure. And even this material stack, it's required that it travels nicely through the long processing, roll-to-roll processing lines. Finally, we come to the testing phase. So, of course, there's the antenna performance. We want to make sure that the antenna is performing like we are promising. And in addition to that, we are doing temperature, humidity, temperature cycling, and bending tests. And bending tests are actually something that we can also do after the post-processing to check that the antenna will survive the next processing phases. So as a conclusion, I would like to say that we have successfully trialed a roll-to-roll manufactured copper antenna on paper, in which we are able to combine the three nice things, so the additive manufacturing, nice performance and price ratio material as a conductive material, and the paper substrate to enable the plastic-free product. If you have any questions, I'm more than happy to answer now or later. And I also have colleagues that can answer all the difficult questions.
Thank you, Tina.
Thank you.
Question?
Thank you. First of all, what's the company that provides the ink, and did you in chance, or will you, willing to connect in your program, you're willing to connect components to the copper? Or currently you're just printing the antenna?
Are you asking that?
I think asking whether you're...
Are we doing the what part or? Yeah, so we're still assessing which part we want to do internally, and of course which part we will use international collaboration.
What is the company that you're working with on the copper?
Yeah.
Another question? Can you speak up?
Sorry, can you repeat the question?
Can you repeat it a bit louder?
Was the question about the material or the printing method?
If you compare this to your printing on paper,
Yeah. Yeah, so yeah, definitely. PET is very stable, not letting moisture or gases through that much compared to paper. So yeah, definitely I feel that you need to make way more tricks to make the paper substrate a good option. And also we've been going through a lot of paper, so paper is not just one standard thing. So definitely you have to do your studies to find a good paper.
Is there any fact on the choice of the specific ink and specific paper on the overall portability of the label?
Yeah, so actually this product also has a sort of an internal structure that we like, so that is related to the end use of the label. And unfortunately, I can't go any deeper, but but yeah, there's a lot of nice properties in this combination.
Further questions? Otherwise, if not, let's thank Tina again.
Thank you.